All right, let's get right into it. We're not just talking about computer chips today, not even close. We're talking about the birth and the crazy fast evolution of a technological brain. I mean, this is the thing that's powering the entire AI revolution. So this is the incredible story of Nvidia's journey and how they ended up building the very engine that's teaching machines how to think. So just let that sink in for a second. This quote really is the key to everything we're going to talk about. We are literally witnessing a world where AI is getting powerful enough to design the next generation of itself. Think about that. It's this incredible feedback loop, and it's changing our world at a speed that's, well, it's just accelerating like crazy. Okay, so here's the game plan. First, how did NVIDIA even get here? Then we're going to dive deep inside this AI brain, both the hardware and the software. We'll look at what it's capable of right now, and then we'll get to the big one. Is this monopoly built to last? All right, section 1. To really get what's happening now, you gotta rewind a bit. For the longest time, when you heard NVIDIA, you thought one thing, right? Graphics cards, gaming, making pixels look pretty. But then they had this genius pivot. They realized that the same tech they used for rendering incredible graphics was perfect for the kind of heavy-duty parallel math that AI needs. So they went from making games look good to building the actual engine for intelligence. What a shift. And check this out. The really wild thing here is just the speed. Look at the dates. It's not just progress, it's acceleration. The V100 in 2017, that was huge. It gave us tensor cores, which are basically specialized little calculators just for AI math. Then, just 3 years later, the A100 comes along and just blows it out of the water. Then the H100 introduces the transformer engine, which is key for all the language models we see today. And now, Blackwell. It's another massive leap. With each step, this AI brain is getting exponentially more powerful. Okay, part 2. Let's get right to the heart of it inside the AI brain. So what is this thing actually made of? We're going to start with the hardware. Think of it as the physical neurons and synapses that provide all that raw horsepower. Okay, just try to wrap your head around this number. 208 billion. Billion with a B. For a little perspective, the human brain has something like 86 billion neurons. Now look, it's not a perfect one-to-one comparison, not at all, but it gives you a sense of the sheer density and complexity we are dealing with here. This is the raw material for building intelligence on a scale we've just never seen. So what does packing 208 billion transistors onto a chip actually get you? Well, you get a massive, massive performance jump. When you compare the new Blackwell chip to the last generation, the H100, it's staggering. It can run a large language model, that's the inference parts, the actual thinking, up to 30 times faster, and it can learn new stuff, that's the training part, up to 4 times faster. So the brain isn't just getting bigger, it's getting way, way quicker at both learning and then actually using what it learned. So, how in the world does it get that fast? Well, one of the secret weapons is something called the transformer engine. The best way to think about it is like a specialized language center in a brain. It's a super smart system that can figure out when to use really precise, detailed math for the important stuff, and when it can cut corners with a good enough calculation to save a ton of time. It's just like when you skim a paragraph for the main idea instead of reading every single word. That intelligent trade-off is exactly how models like ChatGPT can work at such a massive scale. And this right here, FP8 precision, this is that good enough approximation we were just talking about. Instead of using these super long, super detailed numbers for every single calculation, it uses a much shorter, less precise format that's just way faster to crunch. The real genius here was the realization that for a lot of AI tasks, you just don't need 100% perfect precision. And that little efficiency trick, it's pretty much the secret sauce behind those crazy speedups we saw a second ago. This table just lays it all out, plain and simple. It really shows you the crazy leap in just one generation, from the A100 to the H100. Look at these numbers. Transistors, up by almost 50%. Memory bandwidth, which is basically how fast a chip can grab the data it needs, nearly doubled. And then you get to the T-flops. That's just a measure of raw number crunching power. It more than tripled. I mean, every single metric here is just shooting straight up. It's relentless. Okay, section 3, the unbeatable software moat. And this is so, so important. Because you can have the most powerful brain in the world, but without a nervous system to connect everything and tell it what to do, it's useless, right? The hardware, that's only half the story. NVIDIA's real, untouchable advantage comes from the more than 15 years they've spent building the software, the nervous system, that makes all this incredible hardware actually work. And that nervous system has a name, CUDA. It's the software platform that lets developers tap into the power of those GPUs. It has become the default language that pretty much every AI researcher and engineer speaks. And because Nvidia got in on this so early and made it accessible, they built this massive community. Millions of developers who are trained on, comfortable with, and building everything for Nvidia hardware. It creates this powerful lock-in. It's just what everyone knows. And CUDA isn't just this one single thing. It's a whole universe of software tools built on top of it. You've got specialized libraries for everything. Need to build a neural network? There's cuDDN. Want to make your trained model run super fast? That's TensorRT. Building a chatbot? You'll use NeMo. The list just goes on. And here's the kicker. All the big-name AI frameworks that everyone uses, PyTorch, TensorFlow, you name it, they're all deeply integrated and optimized for this CUDA ecosystem. If you want to switch to a competitor, you have to leave all of that behind and start from scratch. It's a huge deal.
And look, you don't have to take my word for it. This quote from a developer on Reddit talking about trying to use AMD's alternative software, well, it says everything. It's a recipe for disaster. This perfectly illustrates the problem. It's not enough to just build a competing chip. You have to build that entire, mature, stable software ecosystem around it. The cost to switch isn't just about money. It's about the headaches, the frustration, the time spent debugging. This right here is the software moat. And so far, no one's even come close to crossing it.
So, let's step back. We've got this incredibly powerful AI brain, and we've got the sophisticated nervous system to control it. So what's next? What's the next evolutionary leap? Well, Nvidia is already working on giving this brain a body. They're taking all that computational power and aiming it squarely at the physical world, at robotics. And this is it, Project Groot. This is Nvidia's moonshot project. They want to create a general-purpose foundation model, basically a mind that can be put into any humanoid robot. The whole idea is to let a robot learn just by watching a person, by understanding natural language, and then figuring out how to copy those movements. It's really the ultimate test for this AI brain. Can it go from the digital world and actually master the physical one? So how do you actually teach a robot to do something new? The process is it's brilliant. It starts with a human operator putting on something like a VR headset and just performing an action. Simple enough. But then the AI takes that one demonstration and uses it to create thousands and thousands of slightly different synthetic examples. Then it spins up all these different virtual worlds for the robot to practice in. And finally, in this massive simulated lab, thousands of virtual robots train over and over again on all that data until they learn a policy, basically a set of instincts for how to do that task in the real world. It's like a factory for creating skills. All right, this brings us to our last big section, and it's the billion-dollar question, isn't it? Is anyone going to crack the Nvidia monopoly? I mean, they seem completely unstoppable. But at the same time, you've got all the tech giants, Google, Meta, Amazon, all pouring money into designing their own AI chips. So is the empire about to fall? Well, the answer is a bit more complicated than that, because the market isn't really breaking. It's splitting. And to really get what's going on, you have to understand that there are two totally different battlegrounds in AI hardware. First, you have training. This is the hard part. It's the research and development, building and teaching brand new frontier AI models from scratch. For this, you need the absolute best, most flexible, most powerful chips on the planet. But then you have inference. This is about taking a model that's already trained and just running it over and over again for millions of users. Think about your ChatGPT queries. For inference, the most important thing isn't raw power, it's cost and efficiency. So let's look at that first battleground, training. In the world of high-stakes, high-margin AI training, Nvidia doesn't just have a lead, they have a fortress. We're talking over 90% of the market. If you are a company trying to build the next big thing, the next GPT-5, or whatever comes after, you're doing it on Nvidia hardware. Full stop. There is no other option. But now, let's flip to the other side of the coin, inference. And this is where the story gets really interesting. The market here is totally fragmenting. You have companies like Meta designing their own custom chips, often called ASICs. An ASIC is basically a chip that's purpose-built to do one thing and one thing only, which makes it super efficient and cheap. So for running something like a recommendation feed for billions of users, these custom chips are way more cost-effective, and they're starting to take over. Projections show they could grab almost half this market. And this brings us to what I think is the most fascinating part of this whole story, the dependency paradox. It's the key takeaway. You have these giant companies, the hyperscalers like Google and Meta, And they are somehow both Nvidia's biggest customers and their biggest competitors. Think about it. They have no choice but to buy Nvidia's most expensive cutting-edge GPUs to train their next-gen models. But then, they turn right around and deploy those models for users on their own cheaper, custom-built chips for inference. So in a weird way, their efforts to compete with Nvidia on inference are actually forcing them to buy more from Nvidia for training. It's a wild dynamic.
So here's the bottom line. Nvidia's monopoly isn't really breaking apart. No, it's actually becoming more concentrated on the single most critical, most profitable piece of the entire AI puzzle, training. And that leaves us with a really big question to chew on. Is having all this power in one place a good thing? Is it a stable foundation that's helping to accelerate the future of AI for all of us? Or is it a walled garden that might end up choking off competition and slowing down innovation in the long run? The answer to that question, well, it's probably going to define the future of AI itself.